Welcome to the segment on decision tree. Before we start with writing some codes on decision tree, I'd like to actually help you to set up the environment. That part is quite important because of some of the library that we're going to make use of. So let's just go through some of these. This is a file that I have as a prompter to help you. So the important part here is that you need to go into your command prompt. All right, so in Windows, go to command prompt and type this line, conda install. Okay, to go to your command prompt, you type cmd. All right, cmd will bring up your command prompt. Okay, and type conda install -- name. All right, this is just to let the conda installer knows that what to follow is the name of your project, and these are all the libraries that you will want to install: Anaconda, Spider, Jupyter, Seaborn, GraphViz, Python-GraphViz. Okay, let me just show you how this is done. Okay, I'm just going to leave mine as project name, and you can easily delete it. Okay, so need to actually create. And again, this might take a couple of minutes to run through. It will ask you whether you want to install this or not. Just type yes and allow it to actually install it for you. Okay, so just type yes to proceed. Okay, in this case, I'm not going to install this. And after you've done that, what you can do is that you can list the different environments that you've created. Okay, and run those by typing activate. In this case, let's just say I want to run this TF and env TensorFlow environment, and just press enter, and notice that it will have been activated. Okay, so let's create, not install. Create is conda create -- the name of your -- name followed by the name of your project, followed by all of these command, and then after it's finished installing, type activate your project name. Okay, so what exactly is decision tree? So I guess the best way is to show you a picture of this. This is one that we're going to see again a little bit later. At least in this case, what I wanted to show you is how the decision tree looks like. It's a little bit like a flow diagram. Let me just minimize this just so that you can actually see the whole tree. Let's just make it 50%, and the height also 50%. Okay. In essence, this is what a decision tree looks like. You have, this is what we call the root node, and then you have the branching. Okay, when all the way down here, these are called the leaf node. Okay, let me borrow this from the internet. You just Google it, and you'll be able to find a whole lot of picture. So you have the root node, which is up here, and then you have the split node, and then the final node here is called the leaf node. Okay, so what we have here is, this is the root node, this is a leaf, this is a split node. So the last, without further splitting, would be called a leaf node. Okay, just so that we actually have some common notation going forward. Okay, now that we have a visual of what a decision tree looks like, let's go into it a little bit more. What we have here is that it tells us that, okay, anything with a petal width that is less than 0.8 in terms of centimeter, if it's true, it's actually put into this bucket. If it's false, it comes into this bucket. And what is true is that you have the samples is 50, meaning there's 50 samples that actually fall into this category whereby the petal width is actually less than 0.8. Let me just give you another visual. This is from a visualizer program called Orange, and also it's a data mining software as well. Okay, so what we have here is we plot the petal length. Okay, let me see if I can put these side by side. Let me just shrink this a little bit. Okay, so that we have two visuals side by side. Okay, so there we have the petal width less than 0.8. Okay, the petal width is this one here, so less than 0.8, but basically it actually splits this category and this category. So anything less than 0.8, it's all classified here. And the tree basically tells us this whole portion is called setosa. So you can see here is actually setosa. And there are 50 of these dots. The value is 50 of the class belongs to setosa is here, and there's none of the virginica as well as versicolor. So here 0, 0 in this part here. So going to down to another split node. So if it's true, it comes to this portion whereby the petal width is less than or equal to 0.8. If it's longer than 0.8, based on this chart that we plot, it should be both the classes. And you can see here is that they do have two classes here, 50 as well as 50 here. And the petal width here is less than 1.75. So there's actually another split over here. Okay, so right here, 1.75, another line is further drawn here, where bulk of the class belongs to the versicolor. Okay, so you have the versicolor here. Okay, so the nodes continue to split on and on it goes. Just basically how the tree is built. Okay, and now that we at least have a general basic idea of what the tree looks like, let's look a little bit further in terms of its usage and where you actually do apply decision tree to. Now, decision tree is still under the supervised learning category. It works for both classification as well as regression. We've seen both. Classification are categorical, A, B, C, D, or based on country names, or cats and dogs, and true and false if it's binary, 0 and 1 if it's binary. And it also works for regression as well. Regression, as we know, as we touched on previously in our classes, a tutorial, is a continuous variable. Okay, and the one thing about decision tree is that it is the foundation or building blocks of random forest. We'll come back to random forest in future section. Now, one of the great thing about decision tree is that it is really attractive because of its the ability to easily interpret what the outcomes is. This is, I guess, another way that people like to call this is that it's a white box. You can see how it actually separates all the categories as you read. It's really intuitive. It's easy to follow. First, it actually split by petal width. Then it's split by the actual petal width length, and then by the petal length itself. After that, it further split by petal width from this category, and on it goes. All right, and that's really the beauty of decision tree, because it is very easy to interpret them. Now, the other thing though is that obviously the natural question is, how does it actually do this? How it works is that it's split based on a set impurity criteria, which we'll come back to. I'll walk through a few criteria that it uses. And when does it stop? Does it continue to keep on splitting? No, it does not. There are a couple of stopping criteria that you can specify, one of them being the depth. You can actually say, look, I really don't want the tree to have more than 2 levels of depth. In this case, what we have is 1, 2, 3, 4, 5 levels of depth. Of course, once it actually starts splitting so far down, you start to have, minuscule, indifferentiable difference further down, and it starts to not make any sense. Okay, final thing that I'm going to cover before we move on to another lecture really is the advantages as well as the disadvantages of decision tree, just so that you appreciate this too before we actually dig into it a little bit more. Now, some advantages of decision trees. Let me just highlight these for it's easier for visualization. The advantages as well as the disadvantages. It's simple and to understand and also to interpret. Okay, this is directly from Wikipedia, if I remember correctly. You can visualize the tree as well. It requires very little data preparation. So that means, unlike a lot of the algorithms that we talked about earlier, where you have to pre-process the data, decision tree, you don't have to. Okay, it is able to handle both numerical and categorical, as we mentioned before. It is possible to validate a model using stats tests. It performs well even if its assumptions are somewhat violated by the true model, in which how the data was originally generated. The one thing that I do want to mention here, sometimes decision tree is also called CAD, which is classification and regression tree. Okay, so it is also known by that name. Okay, we'll come back to look at regression a little later. We'll start with classification first. But there are some disadvantages of decision trees that I need to make you to be aware of. It's straight away. Earlier, you probably would have noticed that it tends to overfit. Sometimes, as you know, when I was talking about the depth, it can go on to many levels, maybe even hundreds, depending on how big your data size is, and it starts to not make any sense actually when it starts to split further down to that level. Some mechanisms have been used to overcome this, such as pruning. This is not supported by scikit-learn. Okay, now I remember where this is from. This is actually directly from I'll just put down the source. Source for this is actually the scikit-learn Python scikit-learn library. Okay, I'll put the link in a little later. Right now, unfortunately, the pruning is not supported, but you can actually set the couple of things. One is the minimum number of samples required at a leaf node. So that means you specify, hey, it must have at least 5 or at least 10. Okay, anything less than that, don't actually split it into a separate leaf or node. And also the other one is setting the maximum depth, which I talked about, is necessary to avoid this problem. So remember this, there are two ways. One is the minimum samples required on a leaf node, and the other one is the depth. Okay, specify the maximum depth that the tree can be built up to. Unfortunately, decision trees can be unstable, and one of the way to overcome that is to combine it using an ensemble. Ensemble really is a combination of decision trees, and we will look at this when we actually get to random forest. The third point here is that it cannot guarantee to return the global optima. Okay, meaning it can actually get stuck in a local minima. So one way is again to use an ensemble, multiple trees rather than a single tree alone. And decision tree learners create biased trees if some classes dominate. So the recommendation then is to balance the data prior to actually fitting the data. There are a few ways to overcome a lot of these decision tree problems, one of them being bagging, the other one is boasting. One uses a voting mechanism, the other one is that it learns from the so-called weaker learner, and where it actually is it failed previously, it keeps improving and keeps training on those. Basically, a bit like human being, the area that you're weak in, you keep learning it to improve in that area. So that really ends the segment on introduction to decision tree. What I'd like you to do right now is I'm going to post you a couple of questions to help you to actually cement what you've learned so far. Let me just show you the questions now. Okay, these are the 7 questions I'd like you to make an attempt on. At least pause the video for a couple minutes. The answer is already in this notebook itself. I won't go through them when I come back, but I do want you to actually walk through them. Just, it will help you to recall some of the things that I said before we actually dive in a little bit deeper in terms of the implementation of it. So first question is, what is the decision tree? What is the first image that pops up in your mind? Where can you apply the decision tree to? And is it numerical problems or categorical problems? What is another name that decision tree is also known by? This is just so that you can actually carry out a conversation with others, and when they actually bring up another name, you know that they're talking about decision tree. So what is the other name? Fourth is, how does a decision tree work? How does it actually split? Okay, what is the actual factor that it used to split those trees? We talked about a bit earlier, but we haven't actually gone into depth. I'm gonna go into depth a little bit more in terms of the mechanism. Okay, so go up the slides and have a look at that, and try to look at that a few times just to actually help you to learn that concept. Fifth question here is, decision tree is the foundation of what machine learning mechanism? okay, on machine learning algorithm. 6 is list and explain 3 advantages of decision tree. So don't just list them. Don't pick at the answer for now. Just try to recall what are these 3 advantages. And also the last and final questions is list and explain 3 disadvantages of decision tree. I've also given you a clue on what are the mitigants, okay, on overcoming these disadvantages. Now, most people just list their disadvantages and probably overlooked the mitigants or how to actually mitigate these problems. So I want you to actually recall those, and then when we actually get to those topics, then you know that these are used to solve some of the problems that decision tree has. So with that, I'm going to end this video. So we've covered these basic concepts earlier. So we cover what is decision tree, what does it look like, where can you apply it to, how does it work, and the foundation of what it is used for, other machine learning algorithm, and finally we also talk about the advantages and also disadvantages. With that, I'm going to stop this video. Thank you for paying attention. When we come back, we're going to go into another topic called training a decision tree. Actually go in and use the scikit-learn library and train a decision tree and see what is the steps involved, and we'll go from there. Look forward to seeing you in the next video. Thank you.